In today's video, I'm gonna tell you how to configure synchronous conveyor belt in KUKA robot. Like this picture. Okay, this is the robot. This is the conveyor. Okay, this is the additional RDC. This is the case, and if you don't want use the additional RDC, you can use the basic RDC inside the robot. You can connect to the conveyor motor encoder to the basic RDC or additional RDC, and this sensor connect to the X23 port, and X23 port 9 pin means 0, 1 pin means 24 voltage, 2 pin connect to the sensor's signal, and additional RDC connect to the CCU X33 port. Okay, so this is the hardware topology. If you use the additional RDC, connect to the X33 port for the CCU. Sensor connect to the X23 2-pin signal. 8 plus 9 should be shorted, means these 2 pins means 0 voltage. 1 pin represent 24 voltage. And this is the topology. I'm going to show you another. This is the RDC connect to the cabinet. You need this cable. One is Ethernet cable connect to the X33. Another should be connect to the PMB cabinet PMB port. One pin represent 24, 0 represent 0. So this is the entire topology, hardware connection. So let's begin the topic. How could we configure in work visual? Okay, so before you configure in work visual, you have to make sure you already installed the conveyor code file in Teach Pendant and in work visual. This is the second step. Oh, okay. The third step, you have to export the RDC XM file. Import this device description. Once you export, you need import this XM file into the work visual. So if you don't know how to do it, you can go back to my previous video. I'm gonna show you one more time. Don't open a project. Choose file, import export. Choose import device file. Choose browse. Choose, and you will find that file. Okay, you will find this file. Okay, then you just import. Once you import successfully, you open the project. You want to configure the function, the conveyor function. Okay, you open it and you activate. Once you activate, then you have to configure at work visual. The first step, you have to add the position track. Add a position track first. Second, you have to add a conveyor. As you can see, we basically use the linear conveyor. Okay, we choose edit. Okay, and we have to place. We have to the second thing, we have to choose the editors. We choose the additional controller settings. We have to enable fast measuring interface. We have to choose it. Fast measuring interface is this. is the sensor connect to the X23 port. This, okay, sensor, okay. Once you confirm this, then you place, you just drag, and you follow the linear conveyor, okay. And once you finish this, you have to make the basement, the conveyor basement, connect to the robot, okay. Open the tool and base management. As you can see, this is the conveyor. You have to drag to the robot, the base. You just simply drag, okay. Once you finish this, you have to check the global. Sometimes you have to check the global settings, the time index. Basically, this is the default one. If something wrong, you have to check, okay. Then once you configured this, then the next you have to check the drive configuration whether it's right or not. So first you have to check the drive configuration. As you can see, the drive configuration is not right because we use the additional RDC. But in this topology, we use the basic RDC from the robot. So it's not right, okay? So what are you going to do? You have to change. You have to change. This is a linear. This is the encode. This is the fast measuring port. So we don't. It's not right. So we have to add another resolver digital, RDC. So what are you going to do? You have to add. You choose add. You choose RDC. Add. Okay. Then you choose connect to this. You get it? This is the, as you can see, this is the fast measuring. This is the RDC. Okay. You have to make sure. Then you make some modification. Once you check the drive configuration, the next you have to check the KCP configuration. You just check it. You check the topology. As you can see, this is right because this is the basic. For the X33, we connect to the another RDC. You get it? At this picture, X33. Okay, so after you checked this is drive configuration is right, then you download the code into the KUKA robot. Once you finish the downloading the code, the configuration, the next you should calibrate the conveyor. Okay, how could we calibrate the conveyor? Go back. Follow this picture. This is the conveyor. We need 3 points position. This is the sensor. This is the part. So the first thing, once you download the configuration in KUKA robot, the next you just choose open the teach pendant. In this teach pendant, I didn't have the correct version, so I'm gonna show you. You log in the KUKA expert password, okay? And you choose the configuration node. You choose the calibrate, and you choose the basically once you download the entire configuration, it will have some choices, linear or others. You choose that option, and you have to configure the sensor first. So you follow the teach pendant instruction. You make the part here, and you start the conveyor. Once part transferred through the sensor activated, then you stop the conveyor. Teach pendant has some indications to tell you signal detect, stop conveyor immediately. So these steps you will activate synchronous signal. The sensor already configured as synchronous signal. Okay, one more time. You put a part here before the sensor. You start conveyor. Part transfer through this position, and sensor activated on teach pendant. So teach pendant, you choose the calibrate. You choose the linear option. Choose to calibrate, measure, linear, conveyor. And once the sensor you configured, the next you click next. Follow this picture. You have this. Once you configure the sensor, the next you have to configure the conveyor coordination. So you first make the robot TCP. Let's assume P1, P2, P3. You have already marked 3 points. Position at conveyor. This is the starting line. This is the starting point. This is the finishing point at the end of the conveyor. This is in the middle of these 2 points. So first you move the robot under the calibrate screen. You move the robot to the P1 and you click apply. Then you follow the teach pendant next, and you move the conveyor a little bit and stop. Then move the robot to the P2, click apply button on teach pendant, and same method, move the robot to P3, apply a button. Then the conveyor coordination will configure. So once you configured this, the next you have to check the encoder, whether the encoder successfully write with the robot or not. This is the diagnose. Okay, choose the Roosevelt digital converter. Choose this, and you can see this is the value, and there is a method to check whether this value is right or not. Should we go this? You stay at this screen on teach pendant, and you put a part here, and once the part activate, pass through the sensor, you stop the conveyor and make the robot stay at random point and start the conveyor one more time. The conveyor will transfer the part a little bit distance. Then you can calculate the distance, the physical distance, compare with this value. Then you will understand, you will know whether this value is identical with the physical distance or not. You get it? So make the part, activate sensor, stop. make the robot stay at random point and make the part moves a little bit distance. Then you can calculate the distance on the teach pendant and the physical distance, compare them. Okay, the robot stays here so that you can mix marks. Okay, so once you configured this coordination and encoder, the final step for you is to establish the sub program on teach pendant. What can you do? So if you install the conveyor code file, you can choose a new module. Because on my teach pendant I didn't install this code file, so I don't have this option. Once you install this option, conveyor code file, you will have similar module like expert function module submit. You get it? You choose that conveyor module, you establish a sub program. So this is once you establish that conveyor module, let's assume should be like this in structure at work visual. It's same at teach pendant. I'm gonna demonstrate. So we have the conveyor we have this structure. So we have the loop, we have this function. This is the move, this is the quit, this is the interrupt function. So let's begin. I'm gonna introduce this function for you. This is the basic structure for conveyor function. So first, initial we can ignore. Okay, let's see the conveyor initial. So we need to pay attention to these 3 interruption. So first interruption means the alarm distance. So you can set the alarm distance. So based on the real situation on your conveyor, this is the maximum distance interrupt function where calls alarm. This is alarm distance. This is the maximum distance. This is the emergency stop interrupt function. Okay, this is the 3 interrupt function, as you can see, correspond with this max distance, emergency, alarm distance. You get it? What you only to do, you set this value. Okay, this is from set this value, you get it. So this is the 3 interrupt. And the next should be conveyor initial, means initial the conveyor. Okay, you understand? So you just type the 1 means conveyor 1, because we have the 1. If you have 1, 2, 3, you type a different number. Okay, and the second function should be conveyor on, means activate this conveyor function. You get it? Conveyor, as you can see. And the following should be a loop. This is the loop cycle. On the loop cycle, we have this function, conveyor follow linear. So I'm gonna open this. So we have these 2 functions. Okay, let's introduce this conveyor follow. This is the linear 1, group 1. Group 1 means move group 1, 2, 3. I will show you. Okay, as you can see, group 1, you can 1, 2, 3. We have the 1, 2, 3. Okay, so this is the conveyor. This is the following maximum time. This is the follow in max distance. We have the, as you can see, max time, and we have the max distance. This is the max following distance. This is the following max time, and this is where cancel the following trigger signal. Input 100 means true. This is the linear 1, group 1. Okay, group 1, you get it. And this also means linear 1, group 1. Okay, and we end the loop, and we're gonna focus on this conveyor move. Conveyor move means you have to teach the position here under this function. Under this move conveyor group here, you have to teach the position here, including the pick up place position here, and also include logic position, a logic code. You get it? So once you under loop, you type the 1 and group 1, convenient 1, and under this subprogram function you have to put the teaching position here. So, and basically, how can you teach this position? You switch the robot to T1 mode, and you run the subprogram. You just establish the module. You just run it under T1 mode, and once you run this mode, the teach pendant will tell you whether you want to teach the position or not. You test the robot, yes. Then what are you going to do? You just make the part move from the conveyor, activate sensor, and make the part stop at some place is convenient for you to record the position. One more time, you establish the conveyor module, and once you understand this structure, you switch the robot to T1 mode. Okay, to the T1 mode, and you run that your subprogram. You just established the conveyor module. You run it on the, and the teach pendant will tell you whether you want to teach the position or not. You choose yes, and then you put a part before the sensor, and you move the conveyor. Once the part activates the sensor, you make the part stay at the position for you to record, for you to teach. This position should be convenient position for you to teach. Then you record the pick position, the waiting position here at the group 1 here. You can add some pick position and waiting position and the logic for gripper open and close. You get it? Then once you finished, this is the entire step for you to configure the synchronous conveyor with the KUKA robot. So if you are master, ignore. So this is today, this video's all content. Hopefully it's useful to you. See you next.